So let's go ahead and get started. So according to my notes, section 4.2, we finished yesterday.
I don't have 4.2. Can I have that?
Yes, ma'am.
Thank you.
And so we were talking about, okay, the signs, the sign of the cosine function and sine function, depending upon what quadrant the angle P or the point P ended up in, right? So it's also, instead of talking in terms of the point P, right, we can talk about in terms of the terminal side of the angle, right? The terminal side of the angle crosses the circle at a point, and that point is P. So wherever P lands, whatever quadrant P is in, right, that will determine the sign, whether the sine function is positive or negative, or whether the cosine function is positive or negative. Okay. All right. So the next characteristic of the cosine and sine functions is that earlier this semester we talked about even and odd functions. And so I have the function f of x, and if it turns out that f of minus x is equal to f of x for all x in the domain of the function, then f of x is an even function. If f of minus x is equal to the negative of f of x, then f of x is an odd function. Well, the cosine function turns out it's an even function. The cosine of minus t is equal to the negative of the cosine of plus t. Okay? Remember that minus sign out front is like minus 1. Right? That's minus 1 times cosine t. So the cosine function is an even function. The sine function turns out it's an odd function. The sine of minus, oh, man, I made a mistake. And you were about to tell me, weren't you? Yeah, I got ahead of myself, okay? The cosine of minus t is equal to cosine t. So cosine is an even function. So what that tells us, right, is an example. The cosine of the angle minus pi over 2 radians equals the cosine of pi over 2 radians plus pi over 2 radians. Okay. And it turns out the sine of minus t is equal to the negative of sine t. So this is minus 1 times sine t. Right? So the sine of minus pi over 4 is equal to the negative, or minus 1, times the sine of plus pi. Okay. And so that helps us, right? A lot of times with the even and odd properties of the cosine being an even function and sine being an odd function, helps us evaluate sine and cosine at negative angles. Okay. All right. Any questions on that? Okay. So you flip over to page 3. we're gonna look at the value of the sine and cosine function for multiples of pi over 2. And the first two cases, we actually covered those at the top of page 2 in your notes, right? So we'll do a brief review. So the angle pi, now the angle isn't drawn, okay? Maybe I can put it quickly on the board. But for pi over 2, so we're doing the upper left-hand corner. The angle pi over 2, remember pi over 2 is the same as 90 degrees. So the angle pi over 2 looks like this. So the angle pi over 2 is actually from the positive x-axis to the positive y-axis. And the terminal side goes through the point 0, 1. So the cosine of pi over 2 is equal to 0, right? Cosine is equal to the x coordinate, sine is equal to the y coordinate. So the cosine of pi over 2 is equal to 0, and the sine of pi over 2 is equal to 1. Okay? That's what it's telling you. In this example over here, the angle pi, which is 180 degrees, right? That's the angle from the positive x-axis to the negative x-axis. The terminal side goes through this point here. This is the point P, and its coordinates are -1 and 0, right? X is -1, y is 0. So the cosine of pi is equal to -1, and the sine of pi is equal to 0. In the third example, we have the angle 3 pi over 2. So the angle 3 pi over 2 here's the initial side. Terminal side goes straight down from the origin. So this is the angle, counterclockwise direction. The angle 3 pi over 2. And the terminal side goes through the point 0, -1 on the unit circle. So the x coordinate is 0, the y coordinate is -1. So the cosine of 3 pi over 2 is equal to 0, and the sine of 3 pi over 2 is equal to -1. In the bottom right-hand corner, we have two coterminal angles. Okay? The angle 2 pi, you know, is one full revolution, right? So the initial side, right, is on the positive x-axis. We rotate it all the way around back to the positive x-axis, right? That's one revolution, which is equal to 2 pi radians. The angle 0 radians is no rotation whatsoever. Okay? The initial side does not get rotated at all. Right? The terminal side and the initial side are on top of each other, but there's no rotation. Okay? So an angle the angle 0 degrees or 0 radians has no rotation. Okay? Here's the unit circle. The initial side, right, is always on the positive x-axis. And so the terminal side is also on the positive x-axis, and there's no rotation from the initial side to the terminal side. Okay? That's an angle of 0 degrees or 0 radians. On the other hand, the angle of 2 pi radians or 360 degrees we have one complete revolution, right? Rotation from the initial side to the terminal side. That's one complete revolution. 2 pi radians or 360 degrees. So 0 degrees zero radians and 2 pi radians are coterminal angles. Remember, coterminal angles in radians differ by an integer multiple of 2 pi. So 0 radians and 2 pi radians, right, they differ by 2 pi. So for both those angles, the terminal side goes through the point 1, 0. 1 is the x coordinate, 0 is the y coordinate. And so the cosine of 0 radians is 1. The sine of 0 radians is 0. And it's also true that the cosine of 2 pi radians is equal to 1. And the sine of 2 pi radians is equal to 0. Okay. So what this is illustrating is for two coterminal angles, they have the same value of the cosine function and the same value of the sine function. That's true for all coterminal angles. They'll have the same value of the cosine function and same value of the sine function. So down below, it brings up this point of periodicity. Okay. For any angle t, if I add 2 pi to it, I create a coterminal angle. Right, they have the same terminal side. Both these angles have the same terminal side. And so the sine of the angle t plus 2 pi and the sine of the angle t have the same value. That's what that's saying. Okay? They both have the same value. And that's true with cosine. The cosine of the angle t plus 2 pi and the cosine of the angle t have the same value. Right? So coterminal angles, right, will have the same value for the sine function, and they'll have the same value for the cosine function. Any questions on that? Okay. All right, so let's look at sine and cosine at t equals pi over 4 radians. So what the graphic is basically trying to say, here's the unit circle. Here's the initial side, right? And here's the angle pi over 4. So here's the initial side. Here's the terminal side. And here's the angle pi over 4 radians. And the terminal side, right, crosses the unit circle at that point, right? That's the point P, okay? And the x and y coordinates at that point P are square root of 2 over 2 and square root of 2 over 2. So both the x and y coordinates have the same value, right, at this point P. Right. The x coordinate at this point is square root of 2 over 2, the y coordinate is square root of 2 over 2. So by definition, right, so from our definition, the cosine of pi over 4 is equal to square root of 2 over 2, the value of the x coordinate, and sine of pi over 4 is equal to square root of 2 over 2, the value of the y coordinate. if you flip over to the top of page 4, we're going to get the exact value of the sine and cosine function for an angle pi over 6 radians. So again, here's my unit circle. Here's the terminal side. Or that's, excuse me, that's the initial side. Here's the terminal side. Right, here's the angle, pi over 6 radians. And so the terminal side crosses the unit circle at this point, and the coordinates for that point are square root of 3 over 2 is the value of the x coordinate, and 1/2 is the value of the y coordinate. So, from our definition, the cosine of pi over 6 is equal to the x coordinate square root of 3 over 2, and the sine of pi over 6 is equal to the y coordinate 1/2. And then we have the angle t equals pi over 3 radians. So again, here's my unit circle. Here's the initial side again, right? It's always along the positive x-axis. Here's the terminal side. Here's the angle pi over 3 radians. Here's where the terminal side crosses the unit circle. And at that point, the x and y coordinates are 1/2 square root of 3 over 2. The x coordinate is 1/2. The y coordinate is square root of 3 over 2. So from our definition, the cosine of pi over 3 is equal to the x coordinate 1/2, and the sine of pi over 3 is equal to the y coordinates square root of 3 over 2. Okay. So those are the exact values of the sine and cosine function for the angles pi over 6, pi over 4, and pi over 3. So this table down here ran out of lead. Need a new pencil. This table down here, you need to know. Okay? You need to know that table. Okay? Along with top of page 3, right? You also need to know for t equals 0 radians, okay? And t equals pi over 2 radians from the previous page. Those are 5 very important angles, okay? So you need to know sine and cosine for those 5 important angles. And so, just to remind you, t equals 0 radians is 0 degrees. Pi over 6 radians is 30 degrees. Pi over 4 radians is 45 degrees, pi over 3 radians is 60 degrees, and pi over 2 radians is 90 degrees. Okay. It turned out to be a very good looking zero. It's a triangle. Okay. And with those 5 angles, we can find sine and cosine for any angle that's an integer multiple of those angles. Okay. All right. Any questions on that? So now we're going to talk about define what a reference angle is, and a reference angle helps us to find the value of sine and cosine for angles that are integer multiples of the angles on the previous page that we learned the exact values of. Okay. So let's look at the definition of a reference angle. The terminal side of an angle of t radians will form an acute angle with the x-axis. So if you look at this first example, here we have the angle t radians. And so the angle between the terminal side here and the x-axis here is an acute angle. Okay? And an acute angle is between 0 and 90 degrees, or 0 radians and pi over 2 radians, right? In the second example, here's the angle T, and the terminal side here makes an acute angle between it and the negative x-axis here. Okay. So that's our acute angle here in that example. And then in the third example, here's the angle t radians. The terminal side is here in the fourth quadrant. And so you can see the terminal side here in the positive x-axis make an acute angle. Okay. Well, there is an angle in the first quadrant that is congruent to the acute angle. So here in this first example, right, the terminal side is in the second quadrant, and so this is an acute angle between the terminal side and the negative x-axis. And in the first quadrant, there's an angle t prime that's congruent to this acute angle. Similarly, in this example, right, here's the acute angle between the terminal side and the negative x-axis. And there's an angle in the first quadrant, t prime, that's congruent to this acute angle. And then the third example, here's the acute angle between the terminal side and the positive x-axis. And there's an angle in the first quadrant, t prime, that's congruent to it. Okay. So using this congruent angle in the first quadrant, we can calculate the value of sine and cosine for this angle t in the second quadrant, this angle t in the third quadrant, and this angle t in the fourth quadrant. Okay. Using the congruent angle for each of those cases. So in this first case, right, where the terminal side of the angle is in the second quadrant, crosses the circle right here, the sine of that angle t will equal the sine of the angle t prime, or it'll equal the negative of the sine t prime. Well, in the second quadrant, we know any angles in the second quadrant, if p's in the second quadrant, cosine is negative and sine is positive in the previous page, right? So the cosine in this example, this first example here, the cosine of the angle t will equal the negative of the cosine t prime. We know the value of the cosine of t prime. Using the fact that we know the value of the cosine of t prime, we can calculate the value of cosine of angle t in the second quadrant. Okay. We know the sine function is positive in the second quadrant, so the sine of the angle t will equal the sine of t prime. And we know the value of sine of t prime. In the third quadrant here, both cosine and sine, right, the terminal side of the angle crosses the circle in the third quadrant, and x and y are both negative in the third quadrant, so both cosine and sine will be negative in the third quadrant. So the cosine of the angle t will equal the negative of the cosine of t prime, and the sine of angle t will equal the negative of the sine of t prime. Okay? We know cosine and sine of t prime, and we can use that to calculate the cosine and sine of t. Okay? And then the third example, right, the terminal side is in the fourth quadrant, right, the point P is in the fourth quadrant, x is positive, y is negative, so cosine will be positive and x will be negative. So the cosine of the angle t is equal to the cosine of the angle t prime, and the sine of the angle t will equal the negative of the sine of t prime. And we'll demonstrate some of this down below in the exercise, okay? And that's why it says here, sine t will equal either the sine of t prime or minus the sine of t prime, not both. You know, when you solve for x, sometimes you get plus or minus the square root of 5. Well, that's not what it's saying. There's not two solutions. There's one solution. Yeah. Yes, sir.
How do you know which quadrant to use to choose?
The what now?
Which quadrant to like get the point from?
Well, this is like the terminal side of the angle t, right? It crosses this point right here. And this, remember, this quadrant 1, quadrant 2, quadrant 3, quadrant 4. And since the point P is in quadrant 2, right? We're in quadrant 2.
So the other side is the initial side?
Oh, the initial side is always on along the positive x-axis.
Okay. So why isn't the other one the terminal?
Say that again.
Why isn't the one in the first quadrant the terminal side?
P to the t prime.
This here?
Yeah.
Yeah. Right? This is the congruent angle. This is the angle, the congruent angle that's congruent to this acute angle. Okay? So the congruent angle is always in the first quadrant. Okay. Are you familiar with the word congruent? Okay, from geometry. Okay. So for every acute angle between the terminal side and the x-axis, okay, there's a congruent angle in the first quadrant. Okay. So the terminal side for the congruent angle will always be in the first quadrant. Okay. Always. Okay. And the reason that we're focused on that is because we know what sine and cosine are for those angles in the first quadrant. And we can use that information to calculate sine and cosine for angles that are not in the first quadrant. Okay. All right. So let's take a look at the exercise. We have to calculate sine and cosine for some angles. Now, some of you had to learn the unit circle in high school, right? And so if you know, you still got that memorized, great. but we're not necessarily gonna memorize the unit circle. We're gonna use what we just talked about to calculate sine and cosine for other angles on the unit circle, okay? All right. So we gotta find the exact value of the sine of the angle 2 pi over 3 radians, okay? So it helps on the far right hand side of the handout. I drew me a little picture. All right, here's the unit circle, X and Y. And 2 pi over 3, I think we drew this angle yesterday, right? It's greater than pi over 2 and less than pi, right? So here's the initial side, and here is the terminal side. So here's the angle 2 pi over 3. So then you gotta ask yourself, what's this acute angle between the terminal side and the negative x-axis? Well, 1/2 rotation is pi over 2 radians, right? The angle between the positive x-axis and the negative x-axis is pi over 2 radians. We subtract 2 pi over 3 from it. Now you gotta deal with fractions, okay? Sometimes it's easier to solve these problems in the degrees and then convert back to radians, okay? Because remember, pi over 2 radians is the same as 180 degrees, and 2 pi over 3 radians is the same as 120 degrees, and 180 minus 120 is 60. Yes, ma'am.
I thought 180 was just pi.
Yeah.
Pi over 2.
Oh, excuse me. So 1/2 revolution is pi radians, okay? Yeah, 1/2 revolution is pi over 2 radians is 90 degrees. Sorry about that. Thank you. So 1/2 revolution is pi radians, and so we're gonna subtract 2 pi over 3 from it. Pi radians is the same as 180 degrees. 2 pi over 3 radians, same as 120. So pi minus 2 pi over 3 is equal to 60 degrees, and you should be able to verify that's pi over 3 radians, okay? So this acute angle here is equal to pi over 3 radians, or 60 degrees. Okay? So pi over 3 radians is the reference angle for 2 pi over 3 radians. Okay? And we know in the second quadrant, the y coordinates are positive, so the sine function is positive in quadrant 2. So that's short for quadrant 2. So the sine of pi over 3 here is going to equal plus sine of pi over 3 radians. And what's the sine of pi over 3 radians equal to from the previous page? Bottom page 4? Square root of 3 over 2, right? Okay. That's how this works with reference angles. Okay. And that's why I said on why you need to know that table on the previous page. Okay. In the next example, we got to find the cosine of 5 pi over 6. So again, here's my unit circle. Now, angle 5 pi over 6. And if you convert that to degrees, that's 150 degrees. You convert it to degrees, right? Which is less than 180, but more than 90. And so the angle 5 pi over 6 looks something like this. And so here's the acute angle between the terminal side and the negative x-axis. How many degrees is that acute angle? 30, right? 150 plus 30 makes 180, right? And in terms of radians, it would be pi over 6, right? So that acute angle is pi over 6 radians, or 30 degrees. Is cosine positive or negative in the second quadrant? Negative, right? So the cosine of 5 pi over 6 is going to equal the negative of the cosine of pi over 6, right? Because pi over 6 is the reference angle for 5 pi over 6. And do we know what the cosine? So remember, the negative of cosine pi over 6 is minus 1 times cosine pi over 6. Do we know what cosine pi over 6 is equal to from the previous page? Square root of 3 over 2, right? So it's minus square root of 3 over 2. So cosine, right, negative is negative in quadrant 2. Any questions on that? So next we have the sine of 7 pi over 4. And again, when you draw 7 pi over 4, it might help to think of, well, what's that angle in degrees? And that angle in degrees is 315. So here's my unit circle. Here's the initial side. And 315 degrees is more than 270, right? But less than 360. So here's the angle, 315 degrees, or 7 pi over 4 radians. And so the terminal side crosses the unit circle at that point. And so this is our acute angle between the terminal side and the positive x-axis. If it's 315 degrees from the initial side to the terminal side, how many degrees is it between the terminal side and the positive x-axis? 45, right? Which is equal to pi over 4 radians, right? So pi over 4 is the reference angle for 7 pi over 4. Is sine positive or negative in quadrant 4? negative. So this is going to be equal to the negative of the sine of pi over 4, right? Negative sine of pi over the same as minus 1 times the sine of pi over 4. And what's the sine of pi over 4 equal to? Square root of 2 over 2. Right? That's why I wrote on there why you need to know that table. Okay? Because you're going to be using those values over and over and over and over and over again. Okay? Or you can memorize the unit circle from high school. Okay? Whatever works for you. Okay? All right. Cosine of minus pi over 3. Now, that's a negative angle, right? Is cosine an even function or an odd function? We just talked about it. It's even. So the cosine of minus pi over 3 radians is the same as the cosine of pi over 3 radians, right? Cosine is an even function. What's the cosine of pi over 3 radians? 1/2 from the previous page, which you need to know, right? So that's why I'm just taking advantage of properties of the cosine and sine function. Then we have the cosine minus 300 degrees. Now you're going to find that there's more than one way to skin a cat when you're solving these expressions, right? You could say, okay, cosine's an even function, so this is going to equal to cosine of plus 300 degrees. I think there's a better way. Remember we talked about periodicity, right? In terms of radians, right? If you add 2 pi radians to an angle, doesn't change the value of the cosine function or the sine function, right? In terms of degrees, right, remember 2 pi radians is the same, and 360 degrees are both 1 revolution, right? So I can add 360 degrees to minus 300 degrees. And that doesn't change the value of the cosine function. Okay? What's minus 300 plus 360? 60. So this is equal to the cosine of 60 degrees. Okay? So let me put a comment in here, right? Cosine has a period of 360 degrees, which is the same as 2 pi radians. $60 degrees is the same as what in radians? Pi over 3, right? And the cosine of pi over 3 is? So the cosine of minus 300 degrees is equal to 1/2. Okay. All right. I want to take attendance real quick, and then we'll get out of here. I know I'm pushing up against the end of the class period, so I'll do it really fast.